find the volume of a solid whose base is a circle. So what I would do is write out the formula for a circle. So the equation of a circle is x squared plus y squared equals, and then it says whose radius is 3. So the area or volume of a circle formula is x squared plus y squared equals r squared. So that means that my equation is x squared plus y squared equals 9. Then I would sketch a circle of radius 3. And then I would start to think about my equation. So if x squared plus y squared equals 9, if I wanted to get this into x or into a y equation, then this would be y equals plus or minus the square root of 9 minus x squared. So oftentimes, we want our equation to be in terms of x equals or y equals, because when we are integrating, I need to be able to separate my variables. So before I even look at or think about part A, B, and C, I'm thinking about rewriting this as a y equals. So it says, find the volume whose cross sections are squares. So in order to find a volume with a cross section of a square, I need the length of the side of the square. So the length of the side of the square would be from any 2 points on that circle. So you have to be able to rewrite the side length so that it's represented by that side length. It could represent this side length. It could represent this side length. And all of the side lengths in between. So I need to come up with a general formula that would represent S. So that S is representative of the area or the length from the top curve to the bottom curve. So that top curve is the positive square root of 9 minus x squared. And the bottom is the negative square root. So that means the length is the top to the bottom. So S is going to equal 9 minus x squared minus a minus square root of 9 minus x squared, or that the length is 2 square roots of 9 minus x squared. So for volume, we're going from left to right. So the farthest point at our left side is -3. The farthest point on x to the right is at +3. And area of a square is S squared. So we're going to take side length S and square it. And dx represents the width of those squares. So that's how you get your volume. It's the area times the width to give you volume. So you could distribute that square in. So that would give me the integral from -3 to 3. 2 squared is 4. And then the square root squared becomes 9 minus x squared. Don't forget your constant of integration, dx. So you could bring out the 4 and then take the antiderivative of the 9 minus x squared. So that's 9x minus x cubed over 3. And we're evaluating that from 3 to -3. Sometimes you will see this written using symmetry. So the area on the positive side is the same as the area on the negative side. So you could also rewrite this as 2 times the integrals of 9x minus x cubed to 3. And then they would evaluate from 3 to 0. So they would double the volume, but only integrate from the middle to the right. And the reason you would rewrite it like this is to give you a 0 when you plug in, as opposed to a -3. So does everybody understand how I can double it since it's symmetric at 0? And you could rewrite your bounds to include that symmetry and double your volume. No. It's just that, like, if you were to go to maybe like an outside resource, like if you go to AP Classroom and watch a video, or if you like maybe would go to Khan Academy, there are times they might show you this method. So I'm just presenting it to you to kind of give you an idea in case you would see it somewhere else. Maybe if you look at, like, I don't know, your Slaters or whatever. Okay, so then you would plug all of that in, and you should get a final answer of 144. Just because I was running out of space and I want it to stay nice. I'm not going to show you like the plugging in. So for anybody that, had questions or maybe missed yesterday, is that kind of helping to see where the volumes are coming from? Again, just seeing it another way. I actually, in this packet, don't kill me, I want to jump to number 6. Okay, number 4, just kidding, number 4 and number 5, even though 5 did not copy very well. I want to jump over to 4 and 5 because we did not talk about volume in terms of dy. So yesterday with you, I did everything in terms of dx. I just want to look at one example in terms of dy. They don't pop up very often, but there are going to be cases where you can't use dx. So I want to make sure you have the skill set to do it in terms of dy. So it says, find the volume of a solid whose base is the region bounded by the curve y equals x cubed. The y-axis, so here's the y-axis, so this is a bound. That's also like x equals 0. We're bounded by the x-axis, or y equals 0, so this line is also a bound. And we're bounded by y equals 1. So the reason I started with my bounds before the curve is because that tells me, okay, y equals x cubed. That goes through 0, 0, and 1, 1. So my graph is here, which means my volume, or my space bounded, is here. So it's like a quarter circular shape in a way. And then it says whose cross sections are taken perpendicular to the y-axis and our squares. So if you look back to that first example, here's the x-axis. My side lengths are perpendicular to the x-axis. So now I need my side lengths to be perpendicular to the y-axis. So these are my s's. So that s length is represented by this curve to this curve. So I'm going to take y equals x cubed and rewrite it as x equals the cube root of y. So that I can represent this length as a function. So now if you think about volume, it's the y values, so you start at 0 and end at 1. A square is s squared, so the length from here to there is the cube root of y. Since it's area of a square, we're going to square that. My variable is y, so my constant of integration is dy. So my squares are kind of coming up in the air this way, as opposed to turned the other way. And now you're just going to integrate the same way you would before. The cubic y squared is the same as 0 to 1 of y to the 2/3 dy. So the antiderivative of y to the 2/3, same rules. Add 1, divide by your new power. So adding 3 over 3 to that gives me y to the 5/3. Writing that over 5/3 is the same as writing 3/5 y to the 5/3. So you get 3/5 times 1 minus 3/5 times 0. So the volume is 3/5. So the terminology in the setup, so it's this statement right there is how I know I have to treat it in terms of dy versus dx. So it's perpendicular to the y-axis, where in this statement, it's perpendicular to the x-axis. So wherever the perpendicular is with respect to, that's how you know what variable. So if it's perpendicular to x-axis, then you're using dx, because that perpendicular is the width. So that's how you get your constant of integration. So in this case, since it said perpendicular to the y-axis, I needed to ensure that my constant of integration was dy. Does that help? So, remember, my drawing skills aren't great, but, yeah, it's, let me pull up this. I have, give me 2 seconds. I have, like, a image that might be able to help you a little more.
It's not that hard to visualize, or to do it without visualizing it for the squares one, but for the triangles one, it's not hard.
Oh, I was in advanced algebra 2. I was like, why did none of those topics match? what we're doing. So 7.3 volume of a solid. So like this is what it, whoops, it helps to hit share screen. This right here would represent the cross sections perpendicular to the x-axis with circular discs. So here's the parabolic curve, and there's your cross sections. So that's kind of very similar to what we are doing in this problem, except for instead of circles, it's squares, and then it's rotated 90 degrees, so it's just with respect to the y-axis instead of the x. So I said, I'm not very good at drawing, but I can find you some of my pictures. So like basically what we're doing in our example is we have a part of this. So our squares are not quite as wide as this because we only have a quarter of it. Let me see if I have. So basically what you're doing is you're taking that square and you're rotating it around that axis to create a three-dimensional shape. So you start with a curve, you create an area under that curve, and then you're rotating it around whatever axis you're looking at to create a shape. So, well, this one might not have been a square. I was just saying, like, that's just, this is a shape. It could be a square, it could be a circle, it could be anything. For this example, it said if we had the curve y equals square root of x. Yeah, it says the slice is a disc. That's what I was going to say. Like, I was jumping through, like, examples to just try to give you the 3D visualization. So this is, again, well, and this is not a topic we have to do. This was from, so like these slides are what I used for CHS, because CHS had to actually take two curves and you subtracted one and you made a disc. This is what you do in BC. So this is another one where you're finding it with the y-axis. So this is a little bit more similar to what we're doing. But this one, a y-axis, I did a circle instead of a square, but very similar idea. Does that help a little bit? Okay. Like I said, I didn't use these notes because these are my CHS notes, but I had a lot of visuals on here to help you. So let's go back to, we'll do one more from this packet with respect to the y's. Let me see if I have one that doesn't have a big weird square on top of it. Don't do I? 5's my last DY example. You mean number 5 at the end of the packet? Or, oh, number 10 on our other packet? Yeah. Well, we can look at number 5. So if you flip all the way to the very, very back page of that packet, this is an old multiple choice question from a past AP exam. This is a NIMSY 5 for 5 handout with just some extra AP multiple choice that are kind of helpful to go through. So it says, let R be the region enclosed by the graphs y equals square root x, y equals e to the x minus 1. And then it says R is the base of a solid whose cross sections are perpendicular to the y-axis. So if you see that, and this is a multiple choice question, you can automatically give yourself a 50% chance of getting this right. Because A and B are not even options. You now have a 50-50 shot to get this correct. In order to get our answer in dy, I need my expressions to be solved for y. So you have to say y equals the square root of x, square both sides, so x equals y squared. So in my equations, I'm looking for x equals y squared, and then y equals e to the x minus 1. To get rid of that and solve for y, you're going to ln both sides. I know, I'm just doing it. And okay, go ahead. Tell me why I don't even need to do this, because I don't. But tell me why. Yep, and how do I know which bounds are correct? Aw, I thought you had it. All right, Bethany, I tag you in. Perfect. You nailed it. It's CD because you have to integrate with respect to the y values. So you got to go from the lower to the upper of the y's. So exactly, C and D are identical except for the bounds. And then the bounds have to be with C and D. Awesome. And that, my friends, is how you do deductive reasoning to get your calc questions correct on multiple choice. Do you want to try another multiple choice question just to try it? So, I think something must have been wrong with the copy machine. Because, like, look, this is, like, missing a huge chunk, too. So, let's look at number 3. So this one is area, it's not volume. So it's important to know the difference between the two. We want to know the area. So area is simply under the curve. So you just want to know underneath. I just want to know what's this green shaded region. I don't want to rotate it. So that doesn't help you eliminate any of these because there's no perpendicular axis. Now what you have to do is be able to think, okay, if I want the area of that, graph A is over here, or line A, so this is one of the equations. And this is one of the other equations. So this is kind of like my top, and this is like my top. So I want to add together two areas that are split at 4, 2. So I need this area, which we'll call A, to be added to that area that we could call B. However, do you see any plus signs in any of those areas for our answers? No. So instead of top for A and top for B, I have to go right to left. Because anywhere I draw in a horizontal line, this is always on the right, and that equation is always on the left. So we're going to integrate with right minus left, which means we're integrating with respect to what variable? Somebody said it. Y. So my answer has to have dy in it. So goodbye A, goodbye B. This part, once again, is almost the same. So where's the difference? Yeah, so which one of those is the correct equation if you solve that for y? Perfect. So once again, ooh, my answer is D. Okay. So packets due the 6-1, 6-4, like all the numbers at the top packets due Monday. If you have any questions on any of the homeworks we've done previously, have those ready for me on Monday. Most of the answers I gave you were odds. If there's one for certain you don't know how to do, you can send it to me. I will gladly even post it like tomorrow. So, although I'm sitting in that movie room with you, so I can't really get a lot done.